Jamb UTME candidate 2026. Here is another must repeat question in Jamb UTME. Questions from alloys. I swear to God, this question must come out for Jamb UTME 2026. If this question don't come out for Jamb UTME 2026, come follow me for us. It must come out. Questions from alloy. Either they reconstruct it or they recycle it, but the topic remains the same. Topic is constant. Questions from alloy. Jamb must repeat question 1. Reads, the constituents of Alnico are aluminium, nickel, and dash. A. Magnesium. B. Cobalt. C. Manganese. D. Copper. What's your answer, Jamb 2026 candidates? Let's find that out. First of all, we would have to know the meaning of alloy and several terms in alloy and alloy making or manufacturing of alloy before we come back to the answer of this question. Let's understand what an alloy is. As you are taking this lecture, you know we don't use textbooks. We don't use textbook to prepare for Jamb UTME. So if you have any textbook there, throw that your textbook away. Just get your pen and your paper to jot down. Because 3 weeks to your Jamb UTME, you are going to need what you have jotted down, what you put down, what you pen down for your subsequent revision. That's what you are going to read before the day of your UTME, or 3 weeks to your UTME exam. That's what you are going to study. It's going to boost your confidence, and you are going to know a lot without reading much, without opening textbook. So you don't need textbook. So get your pen and your paper. Let's go. Jamb must repeat question 2. The question reads, the composition of alloy, palm alloy, is iron and dash. The alloy called palm alloy, the composition is iron and what? A. Copper. B. Nickel. C. Lead. D. Magnesium. What's your answer, Jamb 2026 candidates? Let's find out. Ensure you are penning down. Take your pen and your paper and let's go. Alloys. Take note of the color coding. An alloy is a mixture of 2 or more metals or a metal combined with a non-metal, made to improve strength, hardness, resist corrosion, or other properties. What is an alloy? It's very simple. I swear, this is so easy. An alloy is a metal that are brought together. You combine metal to make it stronger or to resist corrosion or other properties, to make it stronger, to improve strength, to resist corrosion or other properties. And what are these other properties? Other properties like having a strong metal and a light metal. It is strong and light simultaneously. So you are having both the quality of strength and lightness, especially the alloy, the kind of alloy used for aircrafts. You know, the plane, the aircraft needs to be light for it to fly, for it to be able to fly in the air. So you need an alloy that is both strong. You need strength of material and lightness of the material. So also note that alloy is not just only metal and metal. It's not the combination of metal and metal. It can also be the combination of metal and non-metal. For example, metal like steel, okay? You have both iron and carbon in steel, okay? So iron is a metal, carbon is a non-metal. That's an example of an alloy of both non-metal and metal physically combined to improve strength and resist corrosion. Alloy are produced by melting and mixing the components, then allowing them to solidify. Like I said, physically combined together. This is not chemically combined together. They can be separated through physical means, okay? So alloy are produced by melting the components, the two metal or the metal, the non-metal, to form the alloy itself. What do you do? After mixing them under a high temperature, they are subject to high temperature, and after heating them, they melt. And when you combine them, after combining them, ensuring that they form a homogeneous mixture, you allow them to cool down, and as they cool down, they solidify. And what do you get? You get an alloy. Reasons for making alloy. Why do we make alloy? Jamb mainly tests these. The reason why you make alloy, they always test it. And this narrows down to each of the alloy, the uses of each of the alloys, especially the common alloys. Let's look at them. The first one we have here is to increase strength. For example, steel versus pure iron. Steel is more stronger, much more durable, much more malleable than pure iron. Okay? Steel is much more stronger, much more malleable, much more durable than pure iron. You know what malleability is? Malleability is bending metal or folding metal into sheets. So a metal that can be easily folded into sheets means that's the property of being malleable or malleability. There's also another term called ductility. That's drawing metal. The ability for a metal to be drawn into a wire. That's ductility, strength, under strength of material. The second we have here is prevent rusting / corrosion. We are going to treat this a little. We are going to stress into rusting and corrosion a little. For example, preventing rusting and corrosion, you have stainless steel. Okay, that's it. Another reason for it is improve appearance, such as brass. Decoration, okay, it makes the metal beautiful. Ornamental, it's ornamental, it improves appearances, it improves aesthetics. Okay, the next one we have here is low melting point. Okay, so alloy makes metal, it reduces the melting point of metal. You know, for example, the solder, solder used in soldering the parts of electrical appliances. Okay, is used to integrate the parts of electrical appliances. They just melt it with soldering iron and you solder. not only in electrical appliances, it also applies to the mechanical field. Okay, so soda is an example of where alloy is used where alloying is used to reduce the melting point of a metal. The next we have here is increased hardness, such as bronze. Okay, bronze is stronger than copper. Okay, bronze is stronger than copper. Bronze is an alloy of both copper and tin. That brings us to this concept here. The concept we have here is electroplating and galvanization. What is electroplating? Electroplating is the process of depositing a thin layer of one metal onto the surface of another using electrolysis. So it is an electrolytic process whereby a metal is melted and form a thin surface. You use it to coat. You spread it to cover another metal, and it is done electrolytically. Okay, it's done in an electrolytic system. Okay, it's an electrolytic process. Okay, electroplating. And why do we electroplate? We electroplate to prevent corrosion. That's why we electroplate, to prevent corrosion. Prevent it. That's why many of the golds you buy in the market, they are not real gold though. Some of them, they call them iron. That's why they call those golds iron. They are not real gold. They used a lustrous material or a lustrous metal to coat it. They electroplated it. Or it might be electroplated with gold. It might be half gold. That's electroplated. It might be an iron metal that was electroplated with gold. So the front appearance is golden, or the front appearance contains gold, but the inner components or the inner material used for the internal part of the jewelry is not actually gold. This is usually done to reduce costs and also economize expensive and difficult to sort metals such as gold. The next we have here is galvanization. And what is galvanization? Galvanization is the process of coating iron or steel with a thin layer of zinc to prevent rusting. So both of these processes are used to prevent rusting. They all involve coating, but they are different. Okay, so I want you to understand the difference between galvanization and electroplating. In electroplating, is an electrolytic process. Galvanization is not an electrolytic process. You just do it manually. In electrolysis, one metal is used to coat the other, but in galvanization, zinc that is used. Okay, zinc is used to coat iron or steel. That's galvanization. Straightforward. Either iron or steel. Zinc is used to coat it to prevent corrosion. Such iron that has been coated with zinc is called galvanized. Okay, it's called galvanized or galvanized iron. So let's look at alloys and their components next. Alloys and their components. The first alloy we have here is steel, which contains iron plus carbon in certain percentage. Iron is usually higher. Iron is usually up to like 90% of steel or 80% of steel, thereabouts. But iron is higher than carbon. The second we have here is stainless steel. Iron plus chromium plus nickel. So stainless steel contains both iron, chromium, and nickel. Then the third we have here is brass. Copper plus zinc. That's the component of brass. Copper plus zinc. Copper plus zinc. You are going to see this in your UTME 2026. Ensure you are writing down, you are penning down. So the fourth one we have here is bronze, which is copper plus tin. Okay, bronze is copper plus tin. That is the content of bronze. That's why bronze is more luscious than brass. Bronze is more aesthetically pleasing than brass. That's why you have gold, you have silver, you have bronze medal. Okay, but you don't have brass medal because bronze is more luscious. Number 5 is solder. The one we say they normally use to solder, or you understand, to solder item and all of that. So number 5 is solder, and it contains what? Tin and lead. Is used to bring metals together. Okay, to hold metals together. You just do that physically. You solder this metal with this metal. Just melt the solder because it has a very low melting point. So number 6 here is duralumin. Okay, duralumin contains aluminium plus copper plus magnesium plus manganese. Okay, so let me quickly take you through the uses of all the 6 alloys we have here. The first one we have here is steel. What is steel used for? Steel is used in construction. Okay, construction of buildings, civil engineering, and so on and so forth because of its strength. Okay, the second one we have here is stainless steel. Stainless steel is also used for construction, but stainless steel is usually reserved for construction where purity is highly respected. Okay, purity is highly considerable. The substance that needs to be stored in the system needs to be pure. So stainless steel is purer than steel itself. Okay, so the term we have here is brass. So what is brass used for? Brass is used as a conductor. It's also used as a terminal. Brass is also used as non-moving parts of an engine. It's also used for leisure. Okay, for aesthetic, for beauty, for ornaments. Okay, for decoration. The next we have here is bronze. Okay, what is bronze used for? Bronze is used for decoration. It's also used for jewelry, the manufacture of jewelry. The next we have here is soda. I already talked about the use of soda. And duralumin. Duralumin is used for aircraft because of its lightness and durability. Duralumin, durability, is very strong and very light. That's why it's used for aircraft. We have number 7 here. The 7th alloy we have here is nichrome. And nichrome contains what? Nickel and chromium. Nichrome, nickel, and chromium. The next we have here is amalgam. Okay, amalgam contains mercury plus another metal, often silver. So mercury and silver most of the time. Amalgam. The next we have here is number 9, gunmetal. And gunmetal contains copper plus tin plus zinc. The next we have here number 10 is magnesium. Magnesium contains aluminium and magnesium. Number 11, pewter. Pewter contains tin plus copper plus antimony. Number 12, sterling silver. Sterling silver contains silver plus copper. Number 13, bell metal. Bell metal contains copper plus tin, which is usually high in content. Okay, tin is higher in content than copper. Number 14, type metal. Type metal contains lead plus antimony plus tin. Number 15 is Alnico. Alnico contains aluminium plus nickel plus cobalt. Number 16 is Invar. Invar contains iron plus nickel. Number 17 is Constantan. Constantan contains copper plus nickel. Okay, number 18 is cast iron. Okay, cast iron contains iron plus 2 to 4% of carbon. And what are the properties of cast iron? Cast iron are usually hard but brittle. It's used for cooking pots and engine block. Why is cast iron used for cooking pots? Cast iron is hard and is also brittle. Cast iron is used for cooking pots and for engine blocks. Okay, that's the moving part of the engine blocks. Why are they used for this purpose? Because cast iron contains high percent of carbon. It contains the highest percent of carbon, 2 to 4%. And this cast iron, it is because of this high percent of carbon that it contains, it is able to withstand the expansion of metal. And what is that called in physics? It's called thermal expansivity of metal, whereby after a metal has been heated for a long time or a long duration, it begins to expand. So cast metal does not expand. So if an engine block, the cylinder of an engine block is like this, and imagine we didn't use cast iron for that purpose, or use cast iron for the engine block, and when the engine starts combusting in the combustion chamber, the engine heats up, and the hole that is supposed to be like this, because of thermal expansivity, the expansion of the metal, it widens the engine block, and that's already a structural problem. So problem enters the system. So cast iron helps to prevent these defects. So instead of cast iron to expand or stretch, it breaks. That's why it's brittle. Moving on. Number 19, wrought iron. This is the purest form of iron. That's the natural form of iron. Okay, this is the purest form of iron. It contains the lowest percentage of carbon. Okay, and it contains iron plus very small carbon. What is the feature of wrought iron? It's malleable. Okay, it's malleable, which means it can be folded into metal sheets. Okay, it's easily foldable because of the lower percentage of carbon. Unlike cast, that instead of it to bend or expand, it breaks. It's brittle. But this is malleable. It's used to make gates and railings. Number 20 here is hastelloy. Okay, hastelloy contains nickel plus molybdenum plus chromium, and it is highly corrosion resistant. Okay, so hastelloy is highly corrosion resistant. Okay, it can be used highly to prevent rust. On the right hand side of the table we have number 21, permalloy, and permalloy contains nickel plus iron. Usually 80% is nickel while 20% is alloy. Okay, so have that at the nick of your mind. It has a very high magnetic permeability. It's used in transformer cores, okay, magnetic shield, and recording heads. Okay, so that's what permalloy is used for. It has magnetic permeability, magnetic field. Okay, magnetic field passes through it. So it's used for transformer core, to make cores. You know that core, that soft iron core you use for transformers. Those something like this. That is usually in transformer. It's usually made up of permalloy, which is nickel and iron. Haven't treated the types of alloy and their components. Let's go back to the Jamb must repeat question 1 and 2. Jamb must repeat question 1. Remember the question. The question reads, the constituents of Alnico are aluminium, nickel, and dash. A, magnesium. Magnesium is not the answer. C, manganese. Manganese is not the answer. D, copper. Copper is not the answer. Or for your correct option, cobalt. The constituents of Alnico are aluminium, nickel, and cobalt. Let's move over to Jamb must repeat question 2. Jamb must repeat question 2 reads, the composition of the alloy, permalloy, is iron and what? A, copper. Copper is not the answer. C, lead. Lead is not the answer. D, magnesium. Magnesium is not the answer. All for your correct option. Option B, nickel. The composition of the alloy, permalloy, contains iron and nickel.